All right, mental math time. Oop, there we go. Um, this is kind of like that second part of the example of what I was showing you about why the distributive property is useful. We're going to use the distributive property to rewrite 7 times 49 and then evaluate it. Again, you can do it either way. You can do 40 plus 9 or 50 minus 1. The idea is you just have to take usually the bigger of the two, and split it apart into more manageable pieces. I'm going to do the subtraction version of it. So 49 is the same as 50 minus 1. Now, the reason why I chose this one over doing the 40 plus 9 is because I like multiplying by 1. It's really easy. It's the multiplicative identity. The number just stays the same. So when I multiply by negative 1, it just becomes the negative version of that number. So I have 7 times 50 plus 7 times negative 1. 7 times 50 is 350. 7 times negative 1 is negative 7. And so 350 minus 7 is 343. There's my answer. Now, it's very important to know when they ask you to do the distributive property, you turn it into a problem with the distributive property. I believe every single one of you could plug that into a calculator and it would not take you very long. But that's not what I'm trying to get you to practice. I'm trying to get you to practice the distributive property. So make sure you use it. All right. Example 3. Now we're going to use distributive property with the algebraic expressions. We're going to rewrite each expression using the distributive property, which we have to now because we can't just combine them together, and then simplify it as much as we can. Now, distributive property says take the number that you're multiplying the quantity by and multiply it by the first part. Then add in the number you're multiplying by and multiply it by the second part. Now, with this problem, only thing left to do is to just apply my rules of commutative property, association, all the other things that we've got along that we've learned so far, and figure it out. 7 times 3 is 21W. 7 times negative 5 is negative 35. So subtract 35. Now, one thing that I might do sometimes is when I'm writing this out, and I might keep that negative sign here and turn it into minus 7 times 5. All that's happening is I'm just changing where that negative is because I know in my head that 7 times negative 5 is the same as negative 7 times positive 5. So since I know that rule, I kind of like just out of probably a bad habit, I just switch them interchangeably. But these mean the same thing, and they will get you to the same spot of 21W minus 35. Just know that's something I do sometimes. If you ever get lost on why that negative sign changed a position that you weren't expecting, just ask. And I didn't do it on the last example, or the very first example where I had the 2 on the right here. But you can, when you're doing distributive property, if the number you're multiplying the quantity by is on the right side of the quantity, you can keep it on the right side. So I have 6v squared times what I'm distributing by, 4, plus v times 4, minus 3 times 4. Notice there I put the parentheses in a different spot. This is where some problems come in. This is why I always like to have it in the front. But it's all depending on how you want to do it. I'm just using the associative property to really make sure it's clear what's getting multiplied. I know in this part of the distribution, it's negative 3 times 4. So I want to make sure that my negative 3 times 4 is what's happening. Here I'm going to use commutative property, and I have 4 times 6 times v squared. And commutative property, because we always like to have the number part first and then the variable. And negative 3 times 4 is 12. 4 times 6 is... what is 4 times 6? 24? Jeez. I'm rusty coming back from summer too. Plus 4v minus 12. And there is your expression. Now, if this, in the beginning, if you like to always have the distributive number on the left, that's fine. You're just applying the commutative property. And that's those two examples there of applying this distributive property to a couple different examples. More examples and more ideas in the next videos.